Okay, thank you. So, yeah, data management and documentation. Um, Data documentation, this has got to be the most boring and dry topic of the lot, hasn't it? But I, I'm going to say no, despite the fact it was Joaquin forced me to give this one. Because if we don't get it correct, then you go out and do all the work and you collect the data and it's not the right data, it's not the right format, we can't share it and everything else. So we have to get this right at the beginning. So I want to talk briefly on what types of data there are, what data fields are required, data accessibility, and the documentation behind it. So I'll try and keep it nice and brief. So in terms of data types, we can collect data in different ways. Ad hoc data, such as using the iMammalia, so your smartphone app, you take a record wherever you are, there's no strategy behind it. Systematic data, so you're collecting stuff which is constant. So you put a camera out, you will collect everything that goes in front of it. So it's systematic. You can put it where you want. You can also collect it in a more systematic way by having an exact distribution, so you can calculate secondary data such as using the REM. So you can produce secondary data if it's systematic. And then of course you've got metadata. So metadata is about data about your data. So your email, stuff you read, that's the data, but actually who it's from, how important it is, what the topic is, that's your metadata. We really need to understand what these different things are in order to make sure we're collecting them correctly. So ad hoc data, iMammalia and there's others in use. eDNA is also ad hoc data. You can just go out and collect some samples and get some results in. They're record specific. You get information on that record, but you don't get any structure behind it. It's effectively random, but it's still really useful. So we can see example here, all the data we've collected on iMammalia and how that has improved our ability to predict wild boar distribution on the right. So this helps with predicting distribution because we can relate the points to habitat and so on. So it's useful. We can have systematic data. So let's look at MammalWeb that collects images constantly over a period of time. It could be on a random location, just where people happen to have back gardens. They've got bits of woodland, they can put stuff out, but it's a constant effort. So it also permits estimates of absence. So the longer you go without recording a species, the higher probability it's not present. Whereas if you're just doing ad hoc presence, it's quite hard to show something's not there. We can also look at systematic approaches with eDNA by sampling particular areas at particular frequencies. One of the disadvantages with eDNA is you don't know how long you're sampling from. You don't know the temporal window. For your camera, it switches on, it switches off. Your eDNA, how long has that DNA been there? How long does it take to degrade? What's the water flow rate? That all changes your temporal aspect of monitoring. And more recently, we've been using acoustic monitors and looking at sonograms. And the reason we've adopted that in the UK is this chap here, the greater white-toothed shrew, is not supposed to be in England. And it turned up in Sunderland. And we're investigating whether this is the best approach to actually find invasive shrews, because they have high-pitched calls that we can hear if we're 10. Those of us in the room, I guess we no longer hear shrews calling. But we can pick up the sonograms and have a look, and they're different for different species of shrew, for different small mammals and such like. So we can start to differentiate between the species. One of the difficulties with using a sonogram, you're sure when you switch it on and when you switch it off, but you don't know how far away you're detecting the animal. It depends on how loud it calls. So some species you'll detect at 3 meters, some at 5, 6 meters. So there's a little bit of work to do there. We're working it out, but it's all systematic. You can also look at systematic data in terms of collecting lots of it, as we've demonstrated on the right. You can calculate which locations you want to put it at, so you can structure your locations. So this permits estimates of movement rate, density, group size, behavior. So you can see the results we've been generating here, looking at wild boar density in different regions. Now, if I can get it to work, we can also calculate movement rate. So trivial example, but we could calculate how quickly things move. So we can also look at some of the behaviors as well. What time of day are things active and such like. So you can get a lot more out of it. And these are all secondary things. So the primary thing is that species was there, but you can then calculate a lot more secondary data out of it. So one of the things we can do with that is we combine all the data together. So we've got the presence data to work out where things are supposed to be, how likely they are. We can then combine it with the density data to try and produce a density map of species across a country. So we did this systematically in British data a few years ago. So we've got a predicted minimum abundance and maximum abundance, so we can calculate the absolute population estimate for Britain for whatever species. This particular example is red fox, but you can do this for all species in different areas. Unfortunately, the data is so sparse, your confidence intervals are generally very large. But that's the data we have. We have to put up with it. We may be able to do that with acoustic sensors in the future. I suspect it's one of the areas where we might be developing in the next 5 to 10 years. And then we've got metadata. So how were you detecting it? So the camera make and model, the camera settings are important. What method are you using to calculate secondary data? And ancillary data, such as the GIS outline of your survey or your survey path on the right there. So you really need this to know where people have been going, which habitats they've been in. Even things like the weather. These can all affect the data recording. So all of these can be collected. They're not always collected, but when they are, we need to make sure they stay with the data. Now, the data often goes to somewhere like GBIF. So let's look at the data fields. So we've got the sighting specific data. So the absolute minimum, you've got the species, location, and date. But normally there's other things collected as well. What time of day might it be for the camera trapping? What's the area? Do you have a photograph, or was it field sign? What type of hunting is going on in that area? Is it a conservation area and such like? So we've had these topics mentioned before. So you've got the sighting specific data. You've got the secondary data you can generate from that, such as movement rate. That doesn't follow into any general databases. That's separate. And then you've got the metadata, how you collected it. So those are the three kind of real important things that you need to be able to collate. For data access, we really want to share the data as much as possible, because the more data you've got, the easier it is to connect everything up. Okay, we understand that as biologists. The difficulty is how do we get everybody else to share the data with us? And that's one of the questions for workshop, I think. How do we persuade more people to share data in the right format so we can all maximize the use of it? Commonly, all that first data, all the original data goes to GBIF. So species, location, date, nice and simple. It's all organized. Photographic data, well, you can stick this into MammalWeb or Agouti as an archive. So if you're doing a particular species and you could measure it in Agouti, you're not interested in the other species, you could still submit that data somewhere else. And that data will eventually get through to GBIF as well. Now, when you make data available, it's very important the accessibility of it. So I would always encourage everybody to submit the data so it's a Creative Commons CC BY, so anybody can use that data for any purpose. But a lot of people seem to think there's a value to it and they want to make it non-commercial. So they put the NC tag on. The problem with non-commercial is everybody's got a different idea of what it means. So when we looked at that original 2017, we did all the British mammals. We looked at 221 data sets from 65 different providers. we had to email them all to ask for permission. And after 3 months, we still didn't have permission from everybody. Some had simply failed to reply. The email address was out of date. They lost their email in their inbox or whatever. Some people told us, no, that data's commercial because you work for government, you need to pay for it. And some people wanted 10 quid, some people wanted £100. So you have to contact each data provider if you make the data NC, so non-commercial use. We ended up with only 75% engagement in terms of the total data. So we had to do our calculations on 3/4 of the available data because we couldn't access the rest. So it's all very well putting your data in a repository, but it has to be publicly available fully as best you can. And one of the issues is how do we persuade people to do that? The second one is the accuracy at which you submit such data. If it's around about 1 kilometre or so, that's fine for the guy on the left. He would probably use any habitat within 1 kilometre of where you put your fix. But for the guy on the right, the shrew, 1 kilometre doesn't really tell you anything about what habitat he's using. You want to get down to 10 meters, 1 meter. You know, he uses habitat at that scale. So whilst some records you might want to blur because they're considered sensitive, I have had people want to blur wild boar records on iMammalia because they didn't want someone coming to shoot them. I'm going, but they're everywhere. They're not going to go to your garden to shoot them. So we have to persuade people to share the data as accurately as possible. Okay, so documentation, there are still people collecting things on paper, particularly protocols and things like that. Some field data may still be on paper, but let's make it electronic so we can use things like the smart app to collect data. One of the advantages, you're collecting the data real time. So if you're looking at things like to unfind invasive species, you're getting real-time data back. It's much more helpful. If you're collecting things onto an Excel spreadsheet, you really should follow good protocol and hold the metadata. So every Excel spreadsheet in my department ought to have that summary tab on, saying what it is, where the data comes from, what protocols, is there a link to the document that tells you what to do, or I start telling people off. Because 5 years' time, someone will look at that Excel spreadsheet and they have no idea what that means. Where was it collected? What exactly was this column? You know, it doesn't have all the details. So I'm insistent that we have that summary sheet on Excel's. It keeps everything together. We need to contribute to large-scale effort. So lovely example here. Just look at the number of authors. Yeah, it's nice to see so many people contributing to this kind of work, and we just need more of you. Lastly, even if you're not contributing to work that gets published through something like EOW, you can publish that data and the metadata. So the data could go to GBIF, but the methodology and everything else, what happens? So you can publish all of this on these preprint servers, bioRxiv, for example. You don't have to have a full scientific paper. You don't need to be a scientist. So we can promote this to people that are collecting data as a means to just store where all the background is, what the protocol is, how they collected it. So there are a couple of links at the bottom here for metadata organization as well. So I think with data documentation, there's a lot of available methodologies to define how to collect it. We just want to make sure as many people as possible are using them and storing it so you can access it with the data. So I think some of the things for discussion, how do we encourage people to combine and submit data using the standards, and how do we encourage them to make it fully publicly available and not put restrictions on it? How do we encourage people to give us the highest resolution data possible? It's probably not too important for deer, wild boar, foxes. 1 kilometre is okay, but your GPS collects it to within 5-10 meters generally. So why not submit at that level? Everything ought to be electronic. So can we persuade people to adapt these means? Sometimes it's not always possible. If you're out in the field for 5, 10, 15 hours, your phone runs out, the battery dies. Some people prefer to collect it on paper. If that happens, it needs to be transferred electronically as soon as possible to avoid transcription errors. And you should be publishing the metadata somewhere. So everything about how you collect it and where you collect it. It was one of the biggest problems we had. We had quite a few published data on density on, let's say, red foxes in Britain. And they gave us, it was such and such a farm or a woodland in this area. They didn't give the boundary of it. And therefore, you don't know really what that density applies to, what habitat. You don't have that information. So that metadata is actually vital. And we've got to make sure it's all backed up. So it's web storage to keep the integrity, the traceability, and the quality of the data. So you can track down how it's collected and what it's being used for. Okay, thank you.
Yorick. So IT tools could be useful, you say yes or no?
Yeah,
you say yes. Tell us.
There's a few challenges there.
Okay.
So it's okay, it's okay,
Okay,
right?
Okay.
Yorick's
Yeah,
asked me
finish
to
it up.
present the first couple of tools that we've got, and then I'll leave the rest to him. So very briefly, we've got these three products working within ENETWILD. I'll just briefly go over two of them. So iMammalia has been running for since late 2019. It's currently in 17 languages. We could still do with a few more translations. You can see where we've had public launches. We've had over 21,000 records and more than 90 different species. So it's working. In the UK, we've actually got a separate system called Mammal Mapper, which this is kind of copies. Now, the other thing is I've actually found people in Britain using iMammalia because they go abroad. So they like to keep the same system to record everything. So people choose different means of doing things. So we should encourage that, not persuade everybody to use iMammalia. Use anything that gives us data, I think, to my mind. So we've had, despite lockdowns, we've had lots of records submitted. You can see where these are. So I think it's been particularly successful. As you can see, even in Britain, it's not just me recording that data. And the Balkans and the Eastern Europe, I think we've done particularly well, not only with iMammalia, but also with agouti and the camera tracking. So for iMammalia, we've got the percentage of records that have been submitted since 2020. All of these countries in red, at least 50% of the available data on GBIF come from iMammalia. So thank you to everybody that's encouraging this and promoting it. It's really working well. And we can see the sorts of species it's collected. So it was set up to collect data for wild boar, but people don't want to go out and just look at wild boar. They look at whatever wildlife's there. So it's also part of a learning experience for people. I think it gives them some education, gives them something back. And I think that's one of the things we have to do with these tools, is give them something back. The other thing that's important is verifying what species. These were all submitted as weasels on different platforms, not iMammalia. But it's, yeah, the one on the right, those black animals are obviously weasels, aren't they? Look at the size of them. So as biologists, we have to remember that members of the public can't really differentiate between species that we would find very easy. So it's one of the reasons why iMammalia doesn't go for really small mammals. No one's going to tell them apart unless you're a professional. For MammalWeb, so this is the other one, we've got trappers collecting sequences wherever they want to put a camera. So there's no protocol on that. We want to collect as many different sources as possible. And we have multiple spotters. So there's a slight difference between here and agouti. We don't care where the data comes from. All data is really helpful. We get multiple people classifying it, so we get a consensus on it as well. So MammalWeb has been collecting camera trapping from across Europe, and you can see here the distribution of sites. Interestingly, one I think hasn't put the right GPS coordinates in there. It's in the middle of the North Sea. But you can see the number of submissions we've had, over 100,000 since this was set up. And